Alright, round 2. Is it a function? This is the algebraically, finding out algebraically part. Same rule. No first component is repeated, which means that each x only has one y. We can't have x repeated. So, in the first problem here, we see that no matter what x is, it's always going to give y to be whatever x is plus 4. So, to figure it out, you're going to go like this and plug in numbers. We'll just do it like this right now. So when x is -1, just plug it in, -1 plus 4, then y equals 3. So we put it right here, 3. When x is 0, we can already see that it will be 0, so then it would be y would just be equal to 4. And then when x is 1, if we had a 1 here, it would be 1 plus 4, and it would give us y as 5. So, yes, this is a function, and the further we go, it's always still going to be a function. So, I mean, it's always still going to be good. It's going to be good to go. So our domain is -infinity to infinity, and our range is the same thing, because there's nothing holding us back here. We can go on and on and on to negative or positive. Okay, next one. Y equals x squared. So we're going to do the same thing. It's going to be the same thing over and over. Now, when x is, say, -2, -1, 0, 1, we'll see what happens. So when we have negative, I'm going to do the work over here for this one. So when we have y equals 2 squared, -2 times -2 gives us a positive 4. 4. Now when we have -1 here, 1 times -1 gives us 1. When we have 0 here, gives us 0. And when we have 1 here, it will give us 1. So, is this a function? Yes. And now what's our domain? The domain is, again, I'm sorry, 1 equals 1. I didn't write it in. -infinity to infinity. Range, same. Alright, the next one. Same thing. Function. For every x value, are we going to have only one y value? See, now what we're looking at here is to make sure that no x's are ever repeated. We can never repeat an x for a value of y. It'll make more sense when we get to one where it doesn't work. Okay, so x, again, we'll do -1, 0. I'm just picking numbers, like there's no rhyme or reason. So when we have, and that's how you do this, -1 times 3, -1 times -1 times -1. -1 times -1, positive, and then times another negative gives us -1. 0 to the third gives us 0. 1 to the third would just be 1 times 1 times 1. 1. Is it a function? Yes. Domain. Range. Alright. This one. X equals y. You see how it changed? These were all y equals. Now we have x equals y to the 6th. Now, when you see this, when you see a y that is raised to a positive power like this, you can immediately know that it's not a function, because this is y. So let's say for y, we have, let's see, what's one that's going to work? Let's just say x is 1, negative, let's stick with the same thing. Negative 1, 0, and 1. When we have x is negative 1, that's not going to work. Negative 1 equals, y would have to be 1. Okay, here's the problem with it. When we have y, just forget about this. When we have y as a, if y equaled a negative 1, then we would have negative 1, 6 times. But because it's positive, it's still going to give us 3, 4, 5, 6. So that times that is positive, times that is negative, times that is positive, times that is negative, times that is positive. It gives us a positive 1. So in that case, we have x and y. X is negative 1, y is positive 1. But if we were to do a positive 1 for y, it would be the same thing. 1 times 1 times 1, 6 times. And it would also still give us a positive 1. So it would give us this. Right? And in this case, we have broken our rule. Each x can only have one y. Well, this x has a negative and this x has a positive. We have two of the same thing here. We can't have that. So this is not a function. So when you see a y raised to a positive power, it's not a function. However, the domain is going to be the same. Right here. I'm not even going to write it. Negative and positive. Because you can go as far as you want. I'm sorry. No. The domain is always going to be positive. The domain is going to be inclusive of 0. See, because even when you do a negative, this number always ends up positive because this is positive. So the domain for what can this be, it can only be a positive number. It can only be either 0. If y was 0, it would be 0, or it can be positive. But for the range, the y value, we can do any negative number here, and it's still going to give us a positive number. So we can go negative to infinity, positive to infinity. I hope that makes sense. We're about to do it again right here. Same thing. X equals y to the 4th. Okay, so let's say we have y to the 4th. Let's plug in 2. Negative 2 to the 4th. That's going to give us negative 2 times negative 2 times 2 times 2. That's a positive 2 times 2. Positive 4, negative 8, positive 16. Okay, so that was y. When we have a negative 2 as our y, we get a positive 16 as our x. Now when we have a positive 2, and it doesn't matter if you use 2, it doesn't matter if you use 5, any negative number and then the positive number, it's going to end up the same thing. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 8 is 16. So when our y was 2, our x is also 16. Not a function. But again, the domain, what can our x be? These are our x's. What it ends up being, x equals, it's always a positive number, no matter how many negative numbers you put in. I think we got it by now, right? So inclusive of 0, it goes to infinity. The range can be anything. Okay. Next page. Okay, so same thing. I'm just gonna make some numbers up and start plugging them in. So when my x is -2, -4 minus 5, and my y equals -9. Put that in my chart. That's -1. Sorry. Can I get -7? Okay, 0, we can just look at it and know 2 times 0 is going to be nothing, so y is going to equal -5. 1, we can look at it and figure it out. If we put a 1 here, it's going to be 2 minus 5, it's going to be -3, and 2. If we put a 2 here, it will be 2 times 2 is going to be 4, minus 5 is going to be -1, and let's just go one more up, say 5. If we put a 5 here, it will be 2 times 5 for our x, which will give us 10, minus 5. Then our y will equal 10 minus 5, and our y will be 5. Okay, so is it a function? Yes. And what's the domain? Our x, it has no barriers. It can go as far negative or as far positive. What's our range? We see it goes negative, positive. It goes anywhere, that's good. It's good to go. Negative infinity to positive infinity. Next one. Okay. I'm going to start writing these down here. So we have this one, x and y chart. So, -2, -1, 0, 1, 2. Plug them in. When x is -2, then I have positive 12 plus 4, then my y equals 16. When it's -1, let's see, let's do it right here. Negative, I got 6 plus 4, then my y equals 10. 0, we can look at it and figure it out. When x is 0, that goes to 0, and it makes y 4. 1, same thing. When we plug 1 in for x, we will just get -6 plus 4, which will give us -2. And 2. When we plug 2 in here, we'll get -12 plus 4, which will give us -8. So, what's the domain, what's the range? Domain, the x looks like it can go anywhere. Negative infinity to positive infinity. Range, same thing. It's going up, 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 down, down, down. Next one. Okay. These ones. Inequalities. When you see inequality, it's the same thing as when you see a y that is to like squared or to the 4th or to the 6th. It's pretty much never a function. And the reason why is because there's so many different numbers that are less than 3. I mean, that I can put anything in here to make it be less than 3. You know what I mean? I can put negative 5 plus, if my x was negative 5, and then my y would be, you know, anything. I could use y, anything, 3. That, would it still be less than negative 3? Because negative 5 plus 3 would give me negative 2. This would be true. You know what I mean? So if I did put in 3, that's all good and great. Hold on, this is getting a little cloudy. But I could also use x is negative 5 and put something else in for y. I could put negative 5, remember this is what we're doing, and I could use for y, you know, plus negative 5, less than 3. Negative 5 plus negative 5, that would give me negative 10. It would be less than 3. Is that true? Oh, sorry. Got my paper all messed up here. Is that true? Yes, it is true. So it would be, you know what I mean? So I can continue on and on and on and on, and I would continue to have multiple values for x. And remember, for every x, there's only one y. So when you see this, no matter if it had, even if it looks like that, less than or equal to inequalities, like it's never a function. Okay, so what's the domain? The domain is, let's see, for every, well, it's negative to positive infinity, because the more negative or positive I make this, like say I made this very negative, say I made it like negative 101, but I did this positive, you know, 100, it would still give me negative 1. It would still be less than 3, and I could switch it around either way. So they can really be anything. So range, sorry, it's getting a little bit, I should have left myself more room on this paper. I'm going to try to do better on the next paper. Okay, so that's that. Okay, y equals square root x. So you know that under a square root you can't have a negative number. It can be 0 because the square root of 0 equals 0, and it could be 1, the square root of 1 equals 1. But you can never have a negative number under here. So since we already know that, we know that this is a function, because no matter what I put here that's greater than or equal to 0, y is going to be equal to the square root of that number. So yes, this is a function. I need a drink. Hold on. Okay. Now, what is the domain? What can x be? Well, it can be 0, and anything above 0. It can't be negative because you can't have it, just like what I just said. So it would be 0 to infinity, inclusive. And what's the range? The range would be the same thing. 0 to infinity. Okay. The next one. Alright, very similar. Yes, it's a function, because no matter what we put under here, you know. Now what's the domain? The domain, what can x be? It can't be negative, so it has to go from 0 to infinity. However, the range, because right here we have a negative. So no matter what we put in here, once we take the square root of it, it's going to end up being a negative. because no matter what comes out of here, it can't be a negative already. It's not going to do negative, double negative, and then turn into a positive. So our y, which is our range, is going to be from negative infinity to 0. Because if this was a 0, you can't have negative 0, the negative just goes away. So it's like that. Okay. Next one. X times y equals 2. Okay. Well, I don't know. Let's just plug some stuff in. X and y. Negative 2, 0, positive 2. So when x is negative 2, then we have y here equals 2. Let's work it out. Negative 2, that would give us negative 2y equals 2. And we have to get y by itself. So we would divide by negative 2, divide by negative 2. That would give us y equals, because that's going to cancel out, y is going to be negative 2 over 2, which is just going to be 1, negative 1. So our answer is negative 1. 0. If we plug 0 in for x, then it's not going to work. Because if we have a 0, then this whole thing is going to be 0. It's going to be 0 equals 2. So this doesn't work. And if we have 2 for x, we'll have 2y equals 2. Divide by 2 so we can get y by itself. That goes away. Then we have y equals 2 over 2, which just gives us 1. Okay, so the domain and the range. I don't really have much room here. I'll just write it right over here. The domain of this one, which means what can x be? It doesn't work right here. So even though we didn't do negative 1, so we know that the x goes all the way to 0, so it's going to be negative infinity all the way up to 0. It's not inclusive because 0 didn't work. And then there's a union at 0 to positive infinity. Okay? And then y is going to be the same thing. The range is going to be the same thing. Okay? Number 28. xy equals negative 6. So if x is now we have a negative and a negative here, so it makes it go to a positive. Positive 6 over 2 gives us 3. Negative y, we can't have it negative. We have to divide by negative 1. So y equals negative and a negative, 6 over 1. It just gives us 6. 0, again, it doesn't work, because if we put 0 in here, then it doesn't matter what x is. It's never going to equal negative 6, so that one's out. And then 1. 1. So we have y. And then 2. Okay. So is it a function? Yes. I don't know if I said if this one was or not, but the answer is yes. This one is a function as well. Yes. Because these numbers don't ever repeat. What's the range? I'm sorry, domain first. What's the domain? X. Well, it goes to there and to there. So the domain is going to be negative infinity because it can go wherever. Up to 0 doesn't work at 0. So 0, like that, non-inclusive. Union, 0, infinity. And the range is the same thing. I'm sorry, it's not actual U, you know, it's like that. Like that. Okie dokie. I think I might have more here. Oh yeah, one more page. This is a long video. Okay, the next one. Is it a function? Now, the same thing is happening here. You see the square root, we automatically know that we can't have any negative numbers under here. This has to be positive. So we can say 4x plus 1 is greater than or equal to 0, because it can be 0. And it goes to infinity. Okay? The range is always going to be, our y is always going to be positive here. So it's going to be, unless it's 0, 0 to infinity.